Alrighty, so today we're going to be having a look at scale factor and area. So let's take a 1 by 2 block and let us multiply both sides by some k value. And in this case, the k value I chose was 3. Well, if we were to do that, we would now have a 3 by 6 box. And the question is, how has the area been changed? How has this area changed from here to here? We can see that the k is equal to 3, right? The scale factor from the original to the image is 3. But the question is, how is the area affected? Well, the area of the first one is just length times width, which is 2 times 1, which is 2. Whereas the area of the second one is also length times width, but in this case it's 6 times 3, and you can see that we get 18. So the sides have increased by a factor of 3, and yet the area has increased by a factor of 9. The scale factor is the same, but the thing is that area gets affected in a slightly different way. Now imagine we didn't know what the side lengths were. Imagine we didn't know what k was, and instead all we knew was that we had a box that had been enlarged, and we knew that the image's area and the original area. And imagine now we wanted to find out what the scale factor was. Well, it's not as simple as just dividing the two, because if we divide the two, well, we're going to get 18 over 2, which is 9, but we already know what the scale factor is, it's 3. So that means that this is going to be useful, but not entirely useful. Now just imagine what's actually happened here. Because this side has been multiplied by 3, and this side has been multiplied by 3, we've really multiplied by 3 twice. So another way of thinking about that is that the area has been multiplied by 3 times 3 times 3, or even better, 3 squared. And so what we actually use for the area is that k squared, the square of k, is equal to the image's area over the original area. So we can use this formula now to work backwards and find our original k value. So k squared is equal to the image of the area's image, over the original image, which is 18 over 2, which gives us 9. But of course, I don't want k squared, I want k, so we take the square root of both sides. Square root of 9 is 3. And there we go. There's our k factor given based on just a side unit. Now we can actually do this in reverse as well. Imagine I have a box, and the box here has an area equal to 1.5 meters. And then the question is, well, how can I work out the relationship between the two boxes? Well, if I knew the area of this one, I could work out k. But what if I knew that the scale factor, the normal scale factor, is equal to, say, a half? So it means the second one should be half as small. Well, in order to work out the area, well, area is affected not by k, but by k squared. So therefore, to get to here, I would multiply by k squared, and to get back, I would divide by k squared. Because remember, I'm not thinking about the side lengths anymore, I'm thinking specifically about area. So, in this case, k squared is going to be a half squared. Make sure whenever you use a half squared, you always put it in brackets. And it's going to be 1.5 times a half squared. So for the image, area is going to be equal to the original area times k squared, which is just that other formula rearranged. So 1.5 times a half squared gives us 0.375 square meters. These should be square units because that is area. And then we go. So we can also go back and forward as well. So if I knew that the image was something else, then we would be able to divide by k squared instead. So this is how we can actually do it. And the relationship between the area of two shapes is the image of the area divided by the original area. See you in the next one. Goodbye.